Okay, I just start the recording, and now.
I think you need to reshare your desktop.
Yeah. I just will do that. Okay, so let's start. Sorry, that take a little bit longer for everyone, but welcome for joining. I hope the recording works now, but it looks like it because I can see on the top. Okay, I will hand over to you, and you just let me know, or you can do what you can now. Also switch the slides, right, Hüseyin?
Let me check. I clicked.
No. Okay.
Yeah, it's changing, I think.
Okay, just let me know. I'm here, and I can also click if you want. Okay.
I will request remote control from you again.
Okay.
So please grant me.
Did you send?
Yeah, I sent.
So now you have it.
Yeah. So yes.
Okay, we got it.
Finally.
Finally.
Yeah, finally.
Okay.
Somehow I will cover the 10 minutes, no problem.
No
So
problem.
thank you everyone for joining this session. My name is Hüseyin, and I am the software development team lead of Hazelcast Cloud, which is a Hazelcast as a service. Currently, I am working in Hazelcast, but I have collected lots of experience from the previous companies about microservice and the DevOps transition. So you will see two sections within this session, one for the Kubernetes and another for the microservices architecture. So within this session, you will see the Kubernetes related stuffs, environment isolation, multi-tenancy, monitoring, moving to public, and the other Kubernetes related stuffs. But let's start with the Kubernetes first, because we are using Kubernetes because we need to focus on the business logic, and then all the other deployment, releasing, and the scaling, etc. operations should be done very easily within the Kubernetes. As you already know, the Kubernetes is the open source platform for managing the containerized workloads and services, right? And in order to use Kubernetes, there are lots of options. When you have a look at the cloud providers, you can use the managed version of the Kubernetes in Google Cloud, AWS, and Azure. But still, if you are in your data center, you can use lots of technology. For example, you can use the kubespray in order to deploy Kubernetes on your data center. Basically, kubespray uses Ansible on the background. Just define your host informations and then let kubespray deploy the Kubernetes environment for you. That's very simple. Or there's native tools like kubeadmin, and you can use that in order to install and join your worker nodes. So after this point, when you use the Kubernetes, you will mostly focus on business logic, as I said, and all the infra level things will be handled by the Kubernetes for you. Environment isolation is a very important topic in the Kubernetes because when you install it, most probably you will need different kind of environments according to your needs. So let's say that it will be dev, staging, and the prod environment. But let's have a look at this isolation in two categories. One of them is you can set up different Kubernetes clusters for each environment, right? For example, you can deploy cluster 1 for dev, cluster 2 for staging, and the cluster 3 for the prod environment. When you install those 3 clusters, you need to manage them separately. So you will have 3 different contexts inside your kubectl context, and then you need to switch between them in order to do some operation. But a second way is installing Kubernetes, a giant Kubernetes cluster, and you can separate your environment by using namespaces. But here, the tricky part is when you use one cluster and the different namespaces, you need to do a strict isolation by using different kind of technologies. As an example, for example, you can use the network policies not to access between the namespaces. For example, dev environment cannot access to staging, or staging cannot access to prod environment. Here, the prod environment here is just an example. In normal scenario, we don't use prod environment within the non-prod clusters. So this prod environment should be a separate Kubernetes cluster. When you install Kubernetes, and if you are the first user of the Kubernetes, you will see that lots of deployments will be handled inside the default namespace, which is a bad practice to me, because let's say that you are deploying everything into the default namespace, and when you have a look at, when you try to look at something inside default, you will see lots of things. So instead of using default for everything, you can put a logical namespace separation here also. For example, let's say that you have monitoring namespace, microservice, and the worker namespace. Within this architecture, you can put Prometheus, Grafana, and ANSI inside the monitoring namespace. And here, if you want to change something, for example, the config of the Prometheus, you can just switch to the monitoring namespace and then do whatever you want. And let's say that you just wanted to do something with one of your REST services. You can switch to the microservice one and do a couple of operations in the product service, for example. Let's say that you put all of this inside the default namespace. You can go into situation something like you can change something in Prometheus instead of product service, because they all start with the PR, and you can confuse with them. So to be in the safe side, you can limit your context by using namespaces. Again, for example, if you have the cron jobs, you are using Kubernetes cron job, you can use a worker or cron job namespace in order to put all the cron job related stuff inside this namespace. So we talk about the Kubernetes clusters namespace, but in order to switch between this namespace Kubernetes context can be a bit tricky with the kubectl tool. So instead of, you can use the kubesticks tool developed by Ahmed. So basically, there are two binaries inside this project. Kubesticks is for switching your context. As you can see in the example, you can switch your context by a simple command, and just you can see the pods within that context, within that cluster. In same way, if you want to change your namespace, you can just use the Kubernetes command to switch to another namespace. So when you list the help command here, you will see lots of useful options inside this technology. So we have the Kubernetes cluster, right? You have only one and isolated namespaces, or you can have different clusters for different purposes. But let's say that you are inside one environment. For example, we are providing the Hazelcast as a service to the customers. That means we are using same or group of instances to the users, customers. So when you deploy something, when you create a Hazelcast cluster, and multiple customers can have their cluster inside the same world, right? Because we are managing only one or a couple of worlds. And in order to separate these clusters, you can use different options. So we have only one Kubernetes cluster, and within this cluster, we have different namespaces to separate each customer. Of course, we have not only one Kubernetes cluster. You may have different Kubernetes clusters in different regions, but the main point here is even inside the one Kubernetes cluster, you need to share same resources between your customers, right? Very good example on this is using the network policies. When you have a look at here, you will see within this namespace, as you can see, the namespace is C123. Let's say that this is the namespace of the customer 123. And only the requests coming from the monitoring namespace can be allowed within this namespace. Very cool, huh? Because we have Hazelcast cluster within this namespace, and we have a metric collection job inside the monitoring namespace, and this can be make requests to this namespace in order to get some metrics from different kind of sources like Hazelcast Management Center or something like that. But other than that, no other namespaces or no other pod requests can come to another custom. For example, C1 to 4 cannot access C1 to 3, and that is very simple. Let me provide you another example here. Since we are providing this to the customer, that can be different customers for different cloud providers. If we are inside the AWS environment, maybe you already know that the AWS metadata service, right? If you are inside the EC2, you can call this IP in order to get your metadata about EC2 instances. So we do not allow our customers to access this metadata service. So you can do that by using this notation. So egress for the outgoing connection. Let's say that you are inside your namespace and you cannot do any kind of, you can do any kind of request, outgoing request. You can access to Google Cloud or you can access any internet except this IP address, because this IP address resolves the metadata service, but we don't want our customers to make requests to this endpoint because they will know the confidential data otherwise. Within this context, there are two terms, the control plane and the data plane. Maybe you have heard these terms in different places, but basically in control plane, we have microservices, cron jobs, monitoring tools, and this is somehow open to public. For example, when you open the console application, your request will come to here, which is public. And also your UI application making some requests to backend services, microservices. Again, this space is open to public. But the data plane have a restricted access to the outside. For example, the data plane contains MySQL databases, Redis maybe, Hazelcast. There can be lots of data-related technologies here. And only the control plane can access this data plane. So you cannot access this data plane from your computer. We have Kubernetes cluster. Somehow we did the isolation, and we are able to separate our customers from between each other to share same resources, because even we provide some service, it needs to be somehow the cost efficient, right? You have a Kubernetes cluster, and you need to have very good monitoring architecture in order to have a good focus on the business logic. When you search for the monitoring on Kubernetes, you will see most of the time you can see this diagram. So for the monitoring part, we are using Prometheus. Prometheus is capable of collecting metrics from known sources. For example, in Docker world, you already know the cAdvisor. So Prometheus is capable of collecting metrics from cAdvisor. In order to install Prometheus in your Kubernetes cluster, most of the time you need to do this manually. But you can use the operator, which is called Prometheus operator inside your Kubernetes cluster. This operator knows how to install Prometheus and the related components. So you don't need to do anything about this installation. Just add your repo to the system and install the Prometheus operator, and that's all. It will install the Prometheus, the side components, and a couple of custom resources for you. Here, Helm is the package manager of the Kubernetes. So you can use it to install the different kind of packages. So we have Prometheus, and it is collecting the metrics from the default sources. And what about the visualization? So when you install the Prometheus, you will have a basic UI to query some data, see some alarms, and also you can see a simple graph for different time intervals. But you can connect your Grafana to the Prometheus. So if you are using Prometheus operator, you will see that Prometheus will be installed, Grafana will be installed, and the Prometheus will be automatically added to the Grafana as the default source. And this is one of the dashboards from the Grafana. Normally, if you install Grafana manually, you need to prepare your dashboards on yourselves. But if you use Prometheus operator, it will install a couple of predefined dashboards for you to track your Kubernetes cluster. Kubernetes capacity planning is one of them. You can see the system load, memory usage, and the disk space usage here as an example. We said that Prometheus has the metric collection component, and also it has alert manager. Since Prometheus is collecting metrics, you can create any kind of alarm by using that metrics. For example, you can create an alert config in order to notify yourself for unreachable components for more than 5 minutes. This is not an acceptable situation, but this is just an example. So you will be notified if there is an unreachable component more than 5 minutes. As a second example, you will see if you have average latency more than 1 second, you will be notified. So let's say that you have microservice pool, you have 100 microservices, and average latency, if the average latency is more than 1 second, you will be notified. But here you see only the alarm config, but the notifying is the different part. So as a notification, you can set different destinations. It can be email, it can be Slack, it can be Opsgenie in order to create an incident, etc. You can have a look at for the sample configurations. As a nature, you may have different Kubernetes clusters, right? In our case, we have Kubernetes clusters on multiple regions. So what can you do on this situation? Do you want to install this Prometheus on every cluster and manage them separately? Or there is another solution? So since I am saying this one, of course, there is another solution, which is the Prometheus Federation. In Prometheus Federation, basically, you connect the different Prometheus instances to central one. In the example, you can see I have 3 more Kubernetes clusters. Of course, there is Prometheus instance inside it. And inside this federation sample is inside the central one. And this Prometheus core will collect the metrics from those extra 3 resources. When you open the Prometheus, central Prometheus, you will see the extra 3 metrics coming from the different Kubernetes clusters. This is very cool on our case because we have only one dashboard, we have only one Prometheus central one, and we are able to see lots of metrics comes from the different Kubernetes clusters. Until this point, by using those technologies, we are able to construct this dashboard. So whatever you see inside this dashboard actually comes from the Prometheus metrics. So until this point, we are in the black box. I mean this one. So you have different kind of components. You deployed something, but you need to expose these services to the outside, right? For example, you have microservices. Yeah. I think there is a noise from background, but
yeah, I think so too. Just ignore it.
Okay. So until this point, you have microservices. You have lots of components, but what about exposing these services to outside? The important part. In this case, I will mention about the AWS scenario. So you have installed Kubernetes cluster inside AWS. You can use a managed service, or you can use k8s in order to install Kubernetes cluster. But what about moving these services, exposing these services to outside? There is a term which is called Nginx ingress. This is basically when you install the deploy Nginx ingress into your Kubernetes cluster, it will basically create a pod and related services. And since you are inside the AWS environment, it will create a load balancer for you. So basically, you have only one load balancer, and you have an Nginx instance that contains the configs. And of course, you need to have a DNS entry, right? In AWS case, we have root 53. Inside the root 53, you have domain records with the CNAME binded to already created load balancer. So you have domain entries, you have only one load balancer, but what about the traffic? Let's say that example.com/product, example.com/categories, for example. How the traffic goes to necessary desired destination service inside the Kubernetes cluster. In order to do this, we need to add some ingress rules. In the example, this is for the product service ingress entry. When you make a request to example.com with the /product context path, you will see the request will be propagated to the service, which has a name product service, and it will use the 8080 port. This is very simple. So under the one domain or multiple domain, you can define lots of context paths in order to propagate them to the necessary service. So this is very simple deployment here, Nginx ingress. Basically, when you have a look at the Nginx ingress pod, you will see there is an Nginx instance inside the container. Whenever you add an ingress rule, it repopulates the Nginx config. Basically, they have the reverse proxy inside the configuration, and that's all. As an overall picture, you will see we have root 53, and request comes to the load balancer, and by using Nginx rule, it will go to product service, user service, etc. So we have a Kubernetes cluster. We have good monitoring architecture. We know how to allow traffic from the public internet to our services. And right now, we are capable of moving to the microservices part. As you already know, whenever you try to deploy something in monolithic application days, you need to wait lots of time to deploy to production environment, right? For example, you change the product page title, and you need to wait for this for several minutes. I know 45-minute interval deployments for only one instance. So when you compare monolith with microservices, maybe this will be the best candidate. But after switching to microservice architecture, you divide your monolith into multiple services, and all of your problems has gone, right? Actually, in first case, this is very specific to my deployment strategy. So you divide into multiple services, and you provide lots of memory to each of them, and you see you have lots of bills at the end of the month or year. So you need to have some best practices in your microservice architecture in order to fit in with your super Kubernetes cluster. Only the microservice architecture term cannot solve your architectural problem. You need to apply some best practice to have this good architecture. As a first item, I need to mention about the glory of REST. Maybe you have heard this term. There is a maturity, Leonard Richardson's maturity model. This is a very important one if you are using the REST services. There are 4 levels here. On the level 0, it is something like swap services. So you have only one endpoint. You have a payload and XML swap body, you can say that, envelope. And within this envelope, you can provide your action, right? One endpoint, one body, and you provide your action inside that envelope. In level 1, resources, so you have multiple endpoints, but this time you are using the same HTTP method to do everything. For example, you always use get method to create something, get something, update something, or delete something. This is not a bad level, a good level of the REST architecture. But in level 2, you have the HTTP verbs. What is this? So in order to create something, you are using post method. In order to replace, you are using put, patch method for the partial update, delete for the deleting something, right? So this is very good level, but there is another, the better one, the hypermedia controls. In level 3, you are the best. So in this one, in the REST API responses, you will see some embedded resources. Let's say that you get some detail from the user /123, you get the detail of the user 123, and within that response, you may add a couple of extra needed information. For example, you can put links for the comments, articles, or other stuffs. So you have a response, you have some links, or it can be a list response, and you can put the next page link inside that response. So when you do this, these links can be used by the web application, by your mobile application, or any other desktop application. So since you provide your useful information, useful links, you don't need to do any kind of URL generation stuff within your consumer, inside your consumer application. So try to reach this level 3. you have microservices, so you can think that these microservices are like human. In order to interact with each other, they need to have some good language. In order to do this, you can do some kind of, maybe you can use the HTTP request from scratch for every operation, but according to me, this is not the best practice. Otherwise, you can generate some client code for every service or the other topics. Let me provide you 2 examples on this. You can search for the Fein client. In Fein client, basically, you define some interface. This is just a Java example. Within this interface, you provide your Fein client value. This users is basically the service name within your Kubernetes cluster. Inside the Kubernetes cluster, you don't use the IP or the domain notation. You use the service name in order to access between services, because there's an internal DNS service inside the Kubernetes. This is one of the advantages of the Kubernetes clusters. And inside this interface, you see some method signature. And when you make a request when you call this get user method, actually it will call the user service and it will use the user's context path. And within as a request parameter, it will add a user ID parameter to path variable. And of course, it will be a get request. You can use this notation. There are different kind of implementation of Fein client. But as a second option, you can use Swagger documentation part. Basically, you enable Swagger documentation within your project. Let's say that you have a Java Spring Boot project. You just add a configuration, simple configuration, and enable Swagger doc. When you do this, you will have 2 URLs. One of them is for the documentation. When you open your Swagger URL HTML file, you will see a very, very good API documentation page. You can do requests inline right in the documentation. You can search for Swagger path, and you will see a good demo for this. And the second one, which is important, is API specs. So this second one is important. Let's continue. In order to generate the client code for every microservice, you can do this one. There is a Swagger code CLI jar file. Just download it from the Swagger project inside GitHub. When you execute this one, java-jar, Swagger generate, I am saying that just use my spec URL. I just wanted to generate a code base for Spring 1 and just extract this one to this folder. This is very simple, huh? So you already have a documented API and just generate your code base by providing 3 parameters here. So what is the best practice or automation flow for this? Let's say that you just deployed a feature, new feature to your non-prod environment, for example, product service. After the product service deployment, you can trigger another job for the client code generation, because right after deployment, you have a API docs URL, and just trigger the another Jenkins job for the client code generation. And after the client code generation, just tag it for snapshot and put it to the Artifactory. So by using every customer using your snapshot branch can use the new features directly without doing any kind of manual implementation. But for the prod environment, of course, whenever you deploy your, for example, product service, the stable one, you can trigger another Jenkins job to generate your client code for different kind of languages at the same time. So this is very, very time-saving operation for your actual implementation. This was the basic microservice best practice, but what about this, using these microservices within the Kubernetes environment? This is a sample Golang project. Basically, my business logic resides in the app folder, and I prepare a Kubernetes folder that contains deployment as a service YAML files. And also, you see the deploy sh, Docker file, and Jenkins file. So as you can see, everything is stated as a configuration inside the code base. There is no manual operation. So I am not creating a Jenkins job manually inside the Jenkins every time. So I am using Jenkins file notation. Let's deep dive inside this component a bit. So what is the deployment YAML here? Basically, in this configuration, you see we have a project Docker image, right? So this is the event service, and this is a Docker image of this project. I am saying that this project this deployment will have 3 replicas. That means when you deploy this, you will see 3 pods under this deployment replica set and the other stuff. And we also provided some environment variables. One of them is Mongo host here. So when you deploy this one, actually this is a black box. You cannot access this one from the outside. But you can, of course, do kubectl port forward. You can do kubectl exec and see if it is working or not. But basically, this is a black box. In order to expose this to outside, you can use a service notation here. Within this service, you need to be careful about the tagging architecture. So here, when you deploy this one, you are saying that, okay, in order to access this deployment, you need to use this service. But which deployment? How this service maps to a specific deployment? Actually, the main point here is the selector. So this selector is saying that, okay, whenever someone calls me, for example, egress rule, remember that, the egress rule, whenever someone calls me, actually I will find the component that has an app, event app, and I will propagate the request to that deployment of code. This is the main working strategy. So this is how we expose service to the outside. But we said that you can have one cluster, multiple clusters, but how you are accessing this one? Of course, we are using the kubectl, but configuring this one is another topic. So I'm not deep diving this topic right now. Basically, you clone your project, you go inside the project, and you kubectl apply -f and the folder. And when you do this, every YAML file will automatically push to the Kubernetes API by using kubectl command. All the necessary resources will be created on the Kubernetes cluster. But we said that we provide some environment variables, right? But what about the configuration data? You may have DB passwords, some other secrets, etc. Basically, you can use the secrets. In this command, I am saying that in microservice namespace, just create a generic secret. The name of the secret will be product service. And inside this product service, you can say that this is a vault. Inside this vault, I am putting some key DB password, which is equal to another placeholder DB password. Most probably, this comes from some credentials source. It can, for example, if you are using Jenkins file, it comes from the Jenkins credential binding operation. And as an example of this, the first environment variable is the static one, Spring Data Source used by my user. And when you have a look at the second one, the password comes from the secret key ref, and the secret name is product service, and the key is DB password. This is how we bind the confidential data to the deployments and the containers. So we deployed something into Kubernetes environment. Of course, there is a deployment strategies, as you guess, and let's have a look at these architectures. Basically, whenever you push something into Git repository, it will be built, tested, and the deployment to cloud provider, right? This is a very simple step. But when you think of this Jenkins file, we check out code base, we build it, we test it, and we deploy by using deploy sh. So basically, inside Jenkins file, I do not put different complex business logic inside the Jenkins file. If there is something complex, I extract it to the sh file and just call it with different parameters. So when you have a look at the, this is the proactive part, because as you can see, there is a notify select started. And for the failure case, we have notify select failed. Let's say that you deploy something by using Jenkins, and you will be notified for every step. So this is very good if you want to have a proactive environment. Because otherwise, when you deploy something, you will see it will be failed, and you will know nothing about the status of the job. So if you integrate this someplace, it will be better. When you have a look at the deploy sh file, basically we build the image, we tag it, we push it to Docker registry, and then we operate the kubectl apply command, because these YAML files depends on the new Docker image version. But what about the actual strategies? By default, Kubernetes uses rolling upgrade. That means all the instances, for example, we said that there are 3 replicas, and when you do a new deployment, you will see the replicas will be deployed one by one, because otherwise all of them will be down at the same time. That means you will have a downtime, right? So we don't want to get into this situation. So rolling update will be sure about this situation. What about the canary deployment? In canary deployment, basically, we try to simulate our new features in the production environment. Let's say that you put a new feature on your console. And in production environment, basically, you have current application which has 3 replicas. And here, be careful about this one. We have a Docker image version which is 1.0, right? Version 1. When you deploy your new feature, let's say that this is Canary app, it has only 1 replica, but it has different version, which is 2.0, okay? So this contains a different feature. But what is the difference between those 2 deployments? As you can see, the names are different, okay? But when you have a look at this when you have a look at these tags, all of them has the app is equal to event app. That means whenever a request comes to the service will go to both of these deployments. So for the 4th request, 3 of them will go to first one. The 1 of them will go to the second one, which is the new one. So 25 and the 75% will be distributed between these deployments. But what is the next step? Let's say that you install those 2 deployments and you are continuously checking your log management tools, alarm metric sources, etc. You get nothing as an exception within a specific time interval, right? And then you can say that, okay, I need to, let me increase the replica of the new feature. You can do 50-50, 25-75, and finally, you need to have this one. So prod app is my application. I have 3 replicas, and as you can see, the Docker image version is finalized. So let's say that you are using Canary releasing, and on the 25%, you get some exception. There is some core problems inside the system. You can quickly roll back to the previous system, and it will be a good case for specific use cases. But what about the blue-green deployment? In blue-green deployment, it is also very good, the controlled one, but this is a bit expensive when you compare to Canary release, because you need to have exact same environment at the same time in order to simulate this one. You have a current production environment, and you deployed new feature, you deployed in another environment, which is basically the same, but request is currently coming to the current one. Let's say that you tested the new one internally and there is nothing. Maybe you can expose this new environment to your specific customers, and you decide that, okay, this is very stable. You can switch your traffic from the current one to the new one. So basically, we are saying this one blue, green. And after this switching operation, the blue will be green, and green will be blue one. And that's all. So this blue-green deployment contains different strategy, and you can have a look at in detail maybe later in the future. So logging. Let's say that you have a Spring Boot application, again, Java application. You are basically writing every log in the console output, nothing into file, any other place, just into the console output. In Kubernetes, there are 2 types of logs, basically, node level and the cluster level. In node level, basically, you generate logs, and they can cap into the node, and maybe you can do a log rotate. But this is very node specific. When you have a look at cluster level logging, basically you have a daemon set. This daemon set, for example, you have Fluent bit. This Fluent bit is collecting data from the container output logs, and this Fluent bit push this data to the Logstash. Most probably you have a Logstash agent inside your Kubernetes environment, and this Logstash collect these logs and send them to a logging backend. It can be Graylog, it can be Logly, it can be Humio or other Elasticsearch, ALK stack, whatever you want. So in order to look at your logs, you can use your logging dashboard. But when you have a look at this dashboard, you will see, for example, you can see the logs by grouping by the container names. Very simple. For example, shipping service, user service, payment service, you can see every logs in same dashboard. Basically, whatever you use, it can be anything. You need to, right after you create your account, you will have a daemon set configuration YAML file. Just grab it, deploy it to your environment. You can use Helm again. And then right after you do that, you will see all the log generated inside the Kubernetes cluster will be automatically sent to this logging the backend. You have good monitoring system, logging system, they are cool, but sometimes you need to have APM and service mesh system because even your system can be healthy, you may have some kind of application level problems. In order to do this, you can use different strategy. For example, as an open source world, you can use Zipkin, for example. In the Java, so if you are using Spring Boot application, you can use Spring Boot slot in order to generate some trace IDs, in order to do open tracing stuffs. And also you can define your Zipkin URL in order to send these traces to this Zipkin dashboard. This is one alternative. And also you can use the paid resources like New Relic, AppDynamics, Dynatrace, etc. But all of them contains the same strategy. In my case, I will mention about the Instana. So Instana is the APM and tracing tool for your system. Whenever you install this into your Kubernetes cluster, basically it generates your architecture level graph diagram first. So when you install your environment, you can see there is some region-specific infra, the other terms. And also, the important part is if you have a microservice pool, you will see the meshing request mesh from between the microservices. So since you are seeing this one, let me deep dive into the shop service, for example. You can see the error rate diagram inside this specific dashboard. Within this one, let's say that you have an incident within a specific time. You can go here and see, okay, I get a huge latency, but what is that? When you deep dive, drill down the actual request flow, you will see, okay, I have a problem inside the Elasticsearch code. Maybe I am trying to search someone, there is some query applied on an unindexed field, right? Maybe you need to regenerate your analyzer and then make another call. So you can easily detect this kind of problems within your system. By the way, in order to handle this, you don't need to do any kind of specific configurations because when you install Instana, it will automatically grab the metric as sources and then know what is the known sources, Java, Redis, Elasticsearch, it knows everything. And also, if you have a console UI, etc., you can put the JavaScript code also, and you can have a bundled monitoring tool for the APM side. For this specific one here, you can define your alarm again, and in case of any infra or application problem, it can automatically create an incident. It can notify Oxygen, etc. It is very simple. I think we are done here. If you have any kind of question, I can happily answer. Let me check time. Yes. I finished the time.
Maybe you check the chat, or even I think on the bottom there was also Fragen und Antworten. Okay. This is not the correct one. Maybe here, chat. Does anybody has a question? Please.
In chat, I can see nothing. Only in my slides here.
Okay, then when nobody has a question, then thank you very much. Yeah.
Okay, thank you everyone, and I hope have a nice day or evening.
Yeah, if they have any question, of course you can contact him like via Twitter, LinkedIn, whatever. Do you allow me to share your presentation also on the Meetup page? Can I just use it? Sure.
Yeah, of course. You can use the public one.
Perfect. And I will also share the video, which I just will stop now. Okay. I will just close. Okay, stop. Perfect. Great. Thank you very much.